Elon Musk has finally been active on his favorite channel again, tweeting interesting news about the next Starship test flight. Curious to find out which prototype duo is next in line to reach orbit and what kinds of different flame diverter systems are being used in the rocket industry? Yes? Very good, then stay tuned and watch this episode. Hello and welcome back to Alex SpaceX Talks. Today with a Starship Updates Flame Diverter special episode. SpaceX posted a 2-minute recap video of the first Starship test flight on the company's official Twitter channel. Elon himself then took to Twitter that major launch pad upgrades should be complete in about a month, then another month of rocket testing on the pad, and then finally test flight number 2 of Starship. The SpaceX video also indicated that most likely Ship25 and Booster9 will be the candidates for the second test flight. The repairs at Boca Chica are still ongoing, and I'm quite optimistic that the next test flight is only a couple of months away. Personally, I'm really stunned at the daily progress of the SpaceX crew at the launch pad at Starbase, Texas. In anticipation of the upcoming test flight, let's talk in more detail about a crucial step in bringing Starship to orbit: the notorious water-cooled steel plate underneath the orbital launch mount, which should act as a flame diverter system. Recent 3D renders and animations have shown how this plate could look like and what its precise purpose should be. As soon as the 33 Raptor engines of Booster9 ignite, water is being pressed out through dozens of holes on the steel plate. This so-created shield of water should act as a barrier, reflecting the flames and heat away from the steel plate, thus ensuring the safe liftoff of Starship and the integrity of the launch mount. And here we go! SpaceX already tested the first prototype of such a steel plate. The company posted a video showing one of its Raptor engines firing a plume of fiery plasma into the water-cooled plate. The 20-second clip shows the plate cooled by several jets of water during the test, seemingly withstanding the immense power of the Raptor engine. SpaceX hopes that the technology will prevent the creation of another massive crater during Starship's next launch. Flame Diverter Deep Dive. Because of the location of Starbase at Boca Chica, SpaceX cannot dig into the ground deep enough for a classical flame diverter and flame trench used by past and present rocket types. A flame diverter, also known as a flame trench, is a structure or system used to redirect the intense flames and exhaust gases produced during the launch of a rocket. It is primarily employed in a space launch facility to protect the launch vehicle, launch pad, and surrounding infrastructure from the extreme heat and pressure generated during liftoff. Let's have a quick look at the most historic examples of flame diverters in the rocket industry. Saturn V. The Saturn V rocket, which was used by NASA's Apollo program to launch astronauts to the moon, employed a flame diverter system to manage the intense heat and exhaust gases produced during liftoff. The flame diverter used for the Saturn V was also known as the flame deflector. The flame deflector for the Saturn V was a large structure located beneath the rocket's launch pad. It consisted of a series of concrete channels arranged in a specific pattern to redirect the flames and exhaust gases away from the launch pad and the rocket itself. N1. The N1 rocket was a Soviet launch vehicle developed during the 1960s and 1970s for their lunar exploration program. Similar to other large rockets, the N1 also employed a flame diverter system. However, information about the specific design and configuration of the flame diverter used in the N1 rocket is limited due to the program's classified nature and the fact that all N1 launches ended in failure.
How do you Soviets deal with all the tension and stress? Vodka.
Based on available information and historical accounts, however, it is known that the N1 rocket had a flame deflection system that consisted of a series of concrete trenches or channels. Space Shuttle. The Space Shuttle also utilized a flame diverter system. The flame diverter of the Space Shuttle was a large V-shaped structure located beneath the launch pad. During launch, the Space Shuttle's main engines and solid rocket boosters produced a substantial amount of thrust. The flame diverter served as a pathway for these flames and gases, efficiently redirecting them away from the launch pad and structures. Current flame diverter systems, such as the ones used for the Falcon 9 and Falcon Heavy rockets, utilize water deluge systems in addition. These systems spray water onto the flame diverter structure to further mitigate the heat and provide additional protection during liftoff. The water acts as a coolant, absorbing and dissipating the thermal energy. Water deluge systems play a crucial role in rocket launches, particularly during liftoff, by providing an additional layer of safety and protection. These systems involve the controlled release of water onto the launch pad and rocket during various stages of the launch process. The primary purpose of a water deluge system is to suppress flames and mitigate the intense heat generated during liftoff. They are typically automated and activated at specific points in the launch sequence, synchronized with engine ignition and liftoff. That was all for today, folks. I hope that from now on you all know the purpose of flame diverters and water deluge systems in connection with rocket launches. See you soon in my next video. Ciao, ciao!
Cocainum.